Hello everyone, welcome to my channel. In this video, I will explain about linear regression. So this concept belongs to machine learning. First, we will see the definition. So what is the meaning of linear regression? Linear regression is a supervised learning algorithm used to predict continuous values by establishing a relationship between independent and dependent variables. So what is the meaning of linear regression? It is a supervised learning algorithm. Okay, so this linear regression is a supervised learning algorithm. It is used to predict continuous values. Okay, so it is a supervised learning algorithm. It is used to predict continuous values by establishing the relationship between independent and dependent variables. Okay, so what are the key factors about the linear regression? It is a supervised learning algorithm. It is used to predict continuous values. Okay, by establishing the relationship between independent and dependent variables. Now we'll see the examples on linear regression. So the examples of linear regression is, it is used to, here you can see first example is predicting the height of a person based on age. Okay, can we predict the height of a person based on the age? Yes. So almost there is a relationship between age and height. Okay, so this is called as a example of linear regression. Second one is the predicting the price of a car based on car model, manufacturing, year of manufacturing, mileage and capacity. So these are perfect examples of linear regression. Let us move on to types of linear regression models. So the first one is simple linear regression. So this is the first one is the simple linear regression. Second one is the multiple linear regression, and the third one is the polynomial. Fourth one is the logistic linear regression. So completely there are four different types are there in linear regression models. Let us discuss one by one now. So first one is the simple linear regression. So what is the meaning of simple linear regression? Simple linear regression is used to predict a dependent value. So it is used to predict a dependent value. Okay, so dependent value we can say target value using independent variable. So please remember all of you, in the simple there are two things, one is dependent, second one is independent variable. So we are going to predict dependent value based on independent value. It assumes a straight line, a relationship between two variables. Okay, so in order to distinguish between two variables, it assumes one straight line. So this is called as simple linear regression. So one of the most important point, remember all of you, simple linear regression will use only one input variable. Okay, so this is called as what we say simple linear regression. So let us see the equation for simple linear regression. So y is equal to a plus xb. So this is called as what we say linear regression equation. So remember this one all of you. So what is the meaning of y? Y is called as independent variable, x is called as dependent variable, a is called as intercept, and b is called as slope. So this is the graphical diagram of this simple linear regression. Okay, so there is a straight line here, and here we have some data points. So these are called as some data points, and the equation is y is equal to a plus bx. So remember this one, this is called as simple linear regression. Now we'll see the advantages. So what are the advantages of simple linear regression? Easy to understand, it is easy to implement, fast training, and it is good for linear data. Okay, so let us see some examples related to simple linear regression. You can observe on the screen there is some data is there. So the data in the form of table. So first attribute is week, which is expressed with x, and second attribute is y, which is expressed with y. So week is x, sales are y. So week values are 1, 2, 3, 4, 5, and sales values are 1.2 and so on. So what is the meaning of this table? You can observe on the screen. In the first week the sales are 1.2, in the second week the sales are 1.8, third week the sales are 2.6, and fourth week and fifth week. So now we are going to have simple linear equation. We are going to find out the simple linear equation. So in order to find out this equation, we are going to have the expression. This expression is called as y is equal to a0 plus a1x plus e. Okay, so here what is the value of a? A is equal to xy bar minus x bar y bar. Okay, and x square bar minus x bar square. So what is a0? Here this is called as a1, this is called as a0. So let us discuss more. So this is a table. So we write this table here. This x value 1, 2, 3, 4, 5, 1.2 to 3.8. So 1.2 to 3.8. So actually this table is given. So now what we are going to do? So as per this formula, so there is a formula is there. So this is a0 plus this one, a0 plus a1 into x plus e. So for this formula, we are going to find out the a1 value and a0 value. So what is a1? xy bar and so on. a0 is equal to this one. So first let us find out this value. The value is this one. Okay, so this is, we are going to find out this value. Let us find this one first, x square bar. So how to find this x square bar? So already you know we have the data is given x and y. So first we will find out the x square. So in order to find out x square bar, so first we will find out the xi square. So xi square is 1 become 1, 2 become 4, and 3 become 9, 4 become 16, 5 become 25. Okay, so this is about the x square. So this is about this x square. But they asked about the x square bar. So how to find out the x square bar? So please remember all of you. So first we need to perform sum. So what is sum? This sum value is 55. Okay, 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 16 is 30, 30 plus 25 is 55. So in order to find out x square bar, just you do the average. So how to do the average? Sum divided by total number of objects. So total number are 1, 2, 3, 4, 5. So 55 by 5 is 11. Okay, so this is about the xi square. So we need to find out even xi, yi also same. So this is 1 plus 2 plus 3 and so on up to this is 15, and 15 by 3 is 15 by 5 is 3, and yi. So when you add all this we get 12.6, and this average is 2.5.2. So you see we complete this x square bar, the value is this 11. Okay, and let us find out the second value is this xy. So we completed this x square, then we are going to find out xy. So how to find out this xy? So this is about the x and y. So simply we are going to multiply 1 into 1.2, 1.2, 2 into 1.8, 3.6, and so on. Last value is 5 into 3.8, the value is 19. So in order to find out xy bar, so this is called as multiplication. So the final sum is 44.4. But in order to find out xy bar, so just you need to take average. 44 by 4 is equal to 8.888. So this value could be 8.888, and x square. So this x square value could be 11. Okay, so this is 11. This is 8.88. You see here a1. So we are going to find out a1. a1 is equal to xy bar. This is xy bar. a1 is equal to 8.88 minus. So what is the value of x bar? So this is called as x bar because here x is there. So we are going to find out sum plus 15 by 3. This is equal to 3 x bar y bar. So this is 3 into 2.52, 3 into 2.52. So we substitute this equation. So x square bar minus x bar square. So this is equal to 11. So this is value is here x square. X square is this one 11 minus. So this one is the x bar square. So this is x bar 3. So this is square. This is equal to 0.66. So second one is a0 y bar minus a1 x into x bar. So y bar means this one. This is 2.52. Yes, 2.52 minus second one is the a1 x into x bar. A1 value. So this is the a1 value. We find this one. So what is the a1 value? 0.66. Yes, 0.66 into. So what is the value of x bar? X bar is 3. So you write here 3. So the final values of this one is 0.54. So we find the value of a1 and a0. So we need to substitute the values in the linear equation. This is a regression equation which is equal to y is equal to a0 plus a1x. So this is equal to y is equal to 0.54 plus 0.66 into x. So this is called as simple linear regression. Suppose if you want to predict the 7th week, so in the question they have given only 5 weeks. So if at all you want to find out the 7th week, just what you have to do, you observe here. So 0.54 plus 0.66 into x. So here x value is 7. The final answer could be 5.16. Similarly, we can find the 12th week also. Instead of 7, just to multiply with the 12. So this is equal to 8.46. Okay. So let us move on to second one. This is called as a multiple linear regression. So what is the meaning of this multiple linear regression? It is easy to predict dependent value by using 2 or more independent variables. So please remember all of you, in the previous only one dependent is there, one independent is there. But in the multiple regression, we are going to have one dependent followed by 2 or more independent variables. Okay. So dependent variable could be found by using 2 or more independent variables. It assumes linear relationship between dependent variable and multiple independent variables. Okay. So now you see multiple regression of two variables x1 and x given as follows. So y is equal to f of x1 comma x2, and this is the one of the most important equation. Please note down all of you. The equation could be y is equal to a0 plus a1 x1 plus an xn. So that is something like a0 plus a1 x1 plus a2 x2 so on up to an xn plus e. So this is called as what we say multiple linear regression. Now let us move on to third one. This is equal to polynomial linear regression. So polynomial linear regression is a linear regression where the relationship between independent variable and dependent variable is modeled as nth degree polynomial. So in this the keyword is nth degree. So please remember all of you, here we are going to have dependent variable and independent variable. So what is going to be happen? Dependent and independent variables is modeled with nth degree polynomial. So what is the equation for this polynomial linear regression? This is equal to, you can observe here, the regression equation is polynomial linear regression equation is y is equal to a0 plus a1x plus a2x square plus a3x cube so on up to an x power n. So remember all of you, this y is called as dependent variable and x is called as independent variable. So in this a0, a1, a2, so these are called as a0, a1, a2, these are called as independent variables. Okay. So here a0, a1, a2, a3 are called as coefficients and x is called as independent variable. Okay, so remember, polynomial linear regression is useful where the points form a curve. One of the most important question. So when the curve is there, so this is something like a curve. We can say this is called as curve. Okay, so this is about the polynomial linear regression. Now you can observe this is the graph related to polynomial regression. So here the graph could be something like curve. So the equation is y is equal to a0 plus a1x plus a2x square. So this is called as polynomial regression. So the advantages are better accuracy. Second one is the flexible model. Third one is the no need of complex algorithm. Fourth one is the it works for nonlinear data. Okay, so this is about the polynomial regression. So last one is the logistic linear regression. Logistic linear regression is used for classification problems. Okay, so we are going to use for this one as classification problems. It is used for binary classification, that is yes or no, or true or false, or 1 or 0. It uses sigmoid function. Most important point, remember all of you, logistic regression is used with the sigmoid function to convert inputs into probability value between 0 and 1. So this is the graph regarding logistic linear regression. So important graph. So this is called as a logistic linear regression. Okay, so there are three types of linear regressions are there for logistic. First one is the binomial, second one is the multinomial, and third one is the ordinal. So what does it mean by binomial? It uses two classes, either 0 or 1. In the multinomial, it uses more than two unordered classes. So what is the meaning of unordered? So more than 2 means greater. So it starts from 3. This is something like cat, dog, sheep. These are called as unordered classes. So what is the meaning of ordinal? Ordinal, it uses more than 2 ordered classes. So we are going to say ordered nothing but low, medium. So this is called as a ordered. So it's about the logistic linear regression types. So these are the advantages. So what are the advantages of this linear regression for this logistic? First one is it is good for classification problems. Third one is the easy to understand, and fourth one is the efficient. Okay, so this is all about the linear regression models. Okay, so now let me show you the final graph difference between simple and multiple and logistic regression types. So first one is the simple linear regression. So please remember all of you, this is called as simple linear regression. But when I say multiple, this is called as multiple linear regression. Okay, and third one is polynomial. So in this we are going to have some curve. So there is some curve is there. So this is called as this is called as polynomial regression. And last one is we have, it uses something like a sigmoid. You can observe here. So this is the sigmoid curve. So we are going to use something like this one. So this is all about the linear regression models. So thank you for watching this video. Please subscribe my channel. Thank you.